Hi, my name is Adrian Terranova, and I'm here to introduce to you some mobile IP networking examples that I've been working on. Uh, I'd like to say that this is mostly inspired from the FAST 2009 storage area networking conference that was set up, and one of the keynote speakers was Alyssa Henry. Her big example was how the Amazon S3 and EC2 infrastructure provided environments for customers to basically create arbitrary configurations of VM and storage, and also created a mechanism for Amazon themselves to live migrate configurations and containers between locations with no changes to customers. This got me thinking about how they could possibly do it, and that's the root of this talk. My name is Adrian Terranova. My email address is aterranova@gmail.com or adrian.j.terranova@jpmchase.com. Well, let's get inside the container here. In a mobile IP network, you basically have a set of things that you want to create in a mobile network, and you have a series of transit networks that mobile network can then advertise itself through. Outside of the transit network, imagine there were a cloud here, and this is how external providers would connect to you. They would basically connect through the internet over your transit network. The important thing is that as customers connect to you through your transit network, the details of what your specific topology and configuration are hidden in how this mobile network is actually presented. So when this mobile network is associated with this node, traffic will flow down. It will basically be routed over this transit network and then out into the internet and back. There's many different applications for the mobile network. You can have a mobile network with the devices that were in your car. Imagine your radio and your GPS navigation unit, plus basically a smart computer that would understand your gas mileage and where you've been. If you extrapolate a little bit further and imagine that you had an IP cage that was a mobile data center container, you could drag it between locations if you wanted to and plumb them up to your transit networks. And then finally, the idea is that you can put anything inside of an IP cage and have it available to be migrated between locations. Let's talk about what the actual physical components would be. This diagram showing the transit networks that are represented by the circles in the center of the diagram. These are basically the routers that would participate in the routing protocols. This would be a BGP network. This could potentially be an OSPF network, but by no means is OSPF the only way you could do this. There's a router that migrates that's able to basically connect to the different transit networks. There's a dedicated subnet, and this is the address space that you're going to make mobile. There's a series of servers that will live inside of that address space that are related via some mechanism, and they'll basically pass all the traffic out to this gateway router. So if you wanted to see the IP addressing about how this potentially could work, there's an area 10, which would be the stub network in an OSPF segment, an area 0 that's got a very specific addressing scheme relative to the 1.1.1.0/24 network. The internal router address, the OSPF router address would actually be in this network. It would be 1.1.1.1.100/24. That should actually live in this network. And then this router will also be the gateway for this network. So as we add things into the network, let's go ahead and figure out how this routing protocol is actually going to advertise this network. OSPF is going to converge. BGP will then distribute OSPF routes to peers. Imagine that this is your basically internet connected router, and your customers would all come through this 5.5 network. If you look at the 5.5.5.5 routing table on that router, the gateway address for the 192.168.10.0 network is via the 1 router. All of the 1.1.1 routing information is actually removed when it's actually advertised through this BGP network. So the next hop advertised to the external world to get to that network is through this router, At that point, it can transport itself across this transit network and then get back to our basically our area border router. Now, you can go ahead and basically copy your data, or you can physically pick up the container that that router lives in and reassociate it to another transit network. So if you notice, this 1.100 is now associated with this layer 2. It's no longer associated with this layer 2, and the addressing actually overlapped. So it's important that the addressing overlaps so that OSPF can converge with no changes to this gateway. Now, once this gateway is able to associate with this layer 2, OSPF will converge. BGP will then re-announce that it now knows how to get to 192.168.10.0, and that'll be via the .2 router. Once OSPF is no longer announcing that route over here and BGP converges here, everyone will know how to get to that network via this router. Once again, remember, this 5.5.5.5 router is the mechanism that your customers will be able to see that network. Finally, let's go ahead and repeat the experiment one more time. We'll drop the connectivity. We'll migrate it to another layer 2 network that's also addressed with the 1.1.1.0/24. That router will come alive and OSPF will converge. Once OSPF converges, BGP will announce the stub route, the stub network. The stub network is area 10, 192.168.10.0. The 5.5.5.5 routing table, which is where your internet customers will come from and see you. They'll now see that, well, they won't actually see. Your internal routing will point to gateway 5.5.5.5.3. This is also applicable in a cross-site situation. So if you weren't able to physically move the machines, you could copy data out of band from site A to site B. And there's basically a layer 2 SAN or NAS network that you'd have to have on the back end that would replicate your file or block storage from site A to site B. But if you were able to achieve that, and SRDF and TrueCopy and other CIFS and NFS copying protocols all are available that can do this. But if you were able to do that, then you can go ahead and remove the, basically deactivate the router and the servers that are in site A. I'm going to show that it announces first. Sorry, I'm a little particular about how I go through this. So previously, when this association existed from customers, it appears that the gateway is 5.5.5.1. Once you gracefully shut down the servers, remove that association, replumb the data that is those servers and reboot them and start them back up again, and connect them through this alternate OSPF transit network, and then have OSPF converge and BGP reannounce, the routing table will now point to 5.5.5.3. What this provides for you is a mechanism with mechanisms such as vMotion, you could potentially move boxes without actually shutting them down and migrate the state of applications from site A to site B if you were able to have some way to bridge that layer 2 between locations and then gracefully shut down the router and have it restart up on the other side or point to an alternate router when you wanted to fail things over. That's all for this presentation. The problem statement is very, very much needs to be developed along this, but I appreciate you looking at this. Thank you for your time.